Hello, calculus fans. All right, we have another theorem here, a new test. This is a ratio test. If we let L be the limit of the absolute value of a sub n plus 1 over a sub n, then there's three possibilities. If we get a limit that's less than 1, then the series is absolutely convergent. If we get something that's bigger than 1, the series is divergent. If we get L equals 1, the test is inconclusive. What that means is that it might be convergent, it might be divergent. The ratio test can't tell us. Okay, so as an example, let's test this series n factorial over 5 to the n for convergence. Now from now on, anytime you're asked about convergence of a series, that means we want to know, is the series absolutely convergent, conditionally convergent, or divergent? All right, we're going to apply the ratio test. Now, one of the things that tips you off that makes it good for a ratio test computation is the presence of factorials and exponentials. If you have factorials or exponentials, it's good to use the ratio test. All right, so we're going to need a limit of a sub n plus 1 over a sub n in absolute value. So if we work that out, we get the limit of the absolute value of n plus 1 factorial over 5 to the n plus 1 times 5 to the n over n factorial. There's a little bit of algebra that went in there. We're dividing two fractions, so we had to flip one upside down to turn it into a multiplication. If you cancel things out, n plus 1 factorial over n factorial is equal to n plus 1. You really should think about why that's true. Don't just blow past this. It's important to understand how n plus 1 factorial over n factorial cancels out to n plus 1. Then you should also be able to see fairly easily that 5 to the n over 5 to the n plus 1 comes out to be equal to 5. That limit is infinity, and so the ratio test tells us that this series diverges. Okay, that's all for now.